Hello students, in today's lecture I will discuss about polygon filling. Polygon is an ordered list of vertices as shown in the following figure. For filling polygons with particular colors, you need to determine the pixels falling on the border of the polygon and those which fall inside the polygon. So for example, if you want to fill this polygon, then certainly we have to identify all those pixels which are lying inside this area. And if we are able to activate all those pixels which are lying in this area, then we can say that we have filled this polygon. That means we have to highlight all the pixels inside the polygon. And for this polygon filling, we are having two approaches. First is scanline polygon fill algorithm, and second is we are having seed fill. And in seed fill we are having two algorithm. First is boundary fill and second is flood fill. So the first algorithm is scanline polygon fill algorithm. In this, for each scanline crossing a polygon, the area filled algorithm locates the intersection points of the scanline with the polygon edges. So you can see that this is the polygon and this is the scanline, and the scanline is intersecting the polygon edge. So what we have to do, we have to find the intersection points between the scanline and the polygon edge. So you can see that this is one intersection point and this is the second. This is the third intersection point and this is the fourth intersection point. So we need to find the intersection point. Now these intersection points are then sorted from left to right, and the corresponding frame buffer position between each intersection pair are set to be specified fill color. Now what we have to do, we have to find the intersection pairs, and between those intersection pair where the area is inside the polygon boundary, we have to activate all those pixels. Certainly if I am activating all those pixels which are lying inside this polygon, then I can say that I have filled this polygon. So what is happening, we know that the intersection point is at x is equals to 10, then x is equals to 14, then at x is equals to 18, and then x is equals to 24. So the first intersection area is from x is equals to 10 to x is equals to 14. So we have to activate all those pixels which are lying from x is equals to 10 to x is equals to 14, and similarly we have to activate all those pixels which are lying between x is equals to 18 to x is equals to 24. Then all those pixels which are lying between x is equals to 14 to x is equals to 18, we are not activating all those pixels because these pixels are lying outside the polygon boundary. Now here is another example. Now we know that the scanline is moving from top to bottom. So we will start from y is equals to maximum to y is equals to minimum. So start with max y and move to min y, or we can also vice versa it. Now for each scanline, find the intersections of scanline with all edges of the polygon. So here you can see that we are having the intersection point at x is equals to 2, then x is equals to 4, then x is equals to 9, and x is equals to 13. Now in second step we are sorting the intersection by increasing x coordinate, and finally what we are doing, we fill in all pixels between the pair of intersections. So you can see that for scanline number 8, why we are calling it as scanline number 8, because we are keeping the position of scanline with respect to y-axis, and the position of y-axis for this scanline is at y is equals to 8. So for scanline number 8, The sorted list of x coordinate is 2, 4, 9, 13. Therefore, draw a line between 2, 4 and 9, 13. That means activate all the pixels which are in between 2, 4 and 9, 13. So in scanline polygon fill algorithm, we are moving from y is equals to max to y is equals to min. And here you can see that this is the polygon, and we are maintaining one list which is called as active edge list. For example, for scanline 1, the active edge list is AF and AB because this scanline is crossing the polygon edge AF and AB. For scanline 2, the active edge list is it's AB and FE because this scanline is crossing FE as well as this scanline is crossing AB. So here what we are doing, we are maintaining the active edge list. Through active edge list, we could able to conclude that on which polygon edges the scanline is intersecting. Now across each scanline we are having the value of y, but we are not having the value of x. So we have to find this intersection point, and the successive intersection points are calculated by approximation. And we know that in DD algorithm we have already seen that if I am having y value and if I want to approximate the value of x, then the formula could be xi plus 1 is equals to xi plus or minus 1 upon m. If I am approximating the next value, then I have to add the value, that is plus 1 upon m. If I am approximating the previous value, then I have to subtract 1 upon m. So we know that for every scanline we have to calculate x intersection with every polygon side. We can determine the next x intersection value as xi plus 1 is equals to xi minus 1 upon m, where m is the slope of the edge. Now here we are maintaining two pointers. Two pointers are used to indicate the beginning and ending of active edge list. So this is all about scanline polygon fill algorithm, and by using this approach we can fill any polygon, and this algorithm is based on the concept of raster scan system, and the processing of algorithm is same as that we are doing in the raster scan systems. Now the next algorithm is boundary fill algorithm. Before applying boundary fill algorithm, we should keep one thing in our mind, that the boundary of the object should be of same color. If the boundary of this object is different or is having a different color, then we cannot apply a boundary fill algorithm. So in case of boundary fill algorithm, the color of the boundary of the entire object is having a single color. This algorithm is also comes under the category of seed fill algorithm. So in seed fill algorithm, uh, whether it is a boundary fill algorithm or it is a flood fill algorithm, what we are doing, we have to choose a point which is inside the polygon. This algorithm picks a point inside the polygon and it starts to fill until it hits the boundary of the object. So randomly we are choosing any point which is inside the object, and we start filling the object with that from that point with a specified color. If the boundary is specified in a single color, the fill algorithm proceeds outward pixel by pixel until the boundary color is encountered. This method is called as boundary fill algorithm. And we can see that this algorithm has many applications. It is used in interactive painting packages where interior points are easily selected. A boundary fill procedure accepts as input the coordinate of an interior point x, y, a fill color and a boundary color. So whenever you are implementing this algorithm, you have to provide three inputs. First is the interior point x, y, then a fill color, that means which color you want to fill the object, and finally the boundary color, that means what is the color of the boundary of the object. Now starting from x, y, the procedure tests neighboring positions to determine whether they are of the boundary color. So we are moving in all the directions until we could not able to find the boundary color. So this algorithm proceeds in this way. If not, they are painted with the fill color and their neighbors are tested. So what is happening? We are starting from the point x, y, and we are exploring all the successive pixels which are nearby x, y. If the color of those pixels is not of that of boundary color, then we are painting all those pixels with the filled color and we move further. So in this way we can proceed in all the directions. This process continues until all pixels up to the boundary color for the area has been tested. So in this we are using two techniques. First is 4 connected and second is 8 connected. For example, this is the point which we have chosen. In 4 connected method, we are choosing the nearby 4 points or the nearby 4 pixels. So in 4 connected we are choosing these 4 neighbors, while in case of 8 connected we are also choosing the pixels which are on the diagonals. So you can see that from this pixels 4 pixels are connected and from this pixels 8 pixels are connected. 4 connected method is used in partial filling of an object. But if you want to fill the object completely, then in that case you have to use the 8 connected method. And here is the pseudocode which you can use to implement this algorithm. And you can see that in this algorithm we are having the inputs x, y, that is the point which is inside the polygon, and second is the fill color, that means by which color you want to fill the polygon, and the third input is the boundary color, that is the color of the boundary. So this pseudocode is based on the 4 connected pixels. So you can see that if the coordinate of this point is x, y, then you can see that the coordinates of other point will be x plus 1 comma y, x minus 1 comma y, x comma y plus 1, and x comma y minus 1. So here you can see that this point is having the coordinate x plus 1 comma y. This point is having the coordinate x minus 1 comma y. This point is having the coordinate x comma y plus 1, and this is having x comma y minus 1. So in this way we can apply a boundary fill algorithm. Now the next algorithm is flood fill algorithm. The major difference between boundary fill algorithm and flood fill algorithm is that in flood fill algorithm the boundary of the object can be of different colors. So if you want to fill an object whose boundary is of different colors, in that case you cannot apply boundary fill algorithm, you have to apply flood fill algorithm. An area that is not defined within a single color boundary. We can paint such area by replacing a specified interior color instead of searching for a boundary color value. This approach is called as flood fill algorithm. The process of the execution of this algorithm and the previous algorithm is same. In this algorithm also we are choosing the interior point x, y. We start from a specified interior point x, y and reassign all pixel values that are currently set to a given interior color with the desired fill color. If the area we want to paint has more than one interior color, we can first reassign pixel values to so that all interior points have the same color. Using either 4 connected or 8 connected approach, we then step through pixel positions until all interior points has been repainted. So you can see that the working of this algorithm and the previous algorithm is same. Initially we start from any point which is having coordinate x, y. Then we use either 4 connected or 8 connected approach to fill the object, and we continue in all the directions until we get the boundary color. If there is any pixels, if there are any pixel in the object which are pre-filled, then in that case we fill those pixels with the fill color.